Hey everyone, this is Mr. Damien DiVittorio, and I wanted to talk to you about something I'm pretty excited to talk about is watershed delineation. So when we delineate watersheds, we have to use topography maps. And when I was in class, I touched on this a little bit about delineation, but a topography map is a map that has a bunch of lines. So the lines on a topography map show lines of equal elevation, and we're going to look at some examples of this in just a moment. But um, before we start looking at topo maps, I just kind of want to talk about what I mean. So you might see something that looks like this on a topography map, and we can say that this is 300, this is 330, and 360. Now, typically you don't go in increments of 30, but anyway, so what this would denote is a ridge. And we know that because the slope is going down this way, right? This is higher elevation, and this is at a lower elevation. So if we looked at this from a profile, it might look something like this, where this is 360, this is 330, and this is 300. And this would be 330 and 300. And the other thing that's important when we're looking at topography maps to find are valleys. And without context, you'll see that they look very similar. So this could be 440, 420, and 400. And this would be showing us a valley. And if we looked at it in a profile view, it might look something like this, where this is 440, this is 420, and this is 400. Right? And the slope is going down this way. So here I'm on the national map, and I've turned on the contours layer. And what we're going to do is head over here to the mountains in western North Carolina and take a look at the contours and the topographic map and get an idea of how to read this and how we go about the process of delineating. So what I'm going to do is just come right here and say that I would like to delineate to this point right here. So the question is what area is contributing water to this point? Now the process that you could follow is, what I do is I imagine that I'm standing at this point and I'm looking uphill from there, and I'm trying to determine, okay, where is everything going to come down to this point? And what you do and say, okay, this is my point of interest, this is my pour point, my watershed point, my outlet of the watershed. And so what do I do? So the first thing you want to do is look around for high points. And you can see on this topographic map, they've got a high point labeled right here, so 3,600. These are in feet. And they don't have this labeled I don't believe, but we can zoom in and see. So maybe, okay, so this is another high point right here at 3480. So we zoom out, we don't get that granularity, but so remember our point of interest is right here, and we've got a high point here. We know we've got another high point right here, and so with that we can really begin to delineate the watershed. So I'm going to turn this drawing tool back on, and we'll go from there. Oops. So this is our delineation point, our point of interest. And let's start with the delineation process. So we've marked out some high points. And we've got one here. Got one here somewhere. That's pretty horrible. All right. And like I mentioned before, we can see that this is a 3000 contour. This is a 2600 contour, and you can see this 2600 falls all the way this way. So this is 2600 all the way across here. This 3000 is 3000 feet in elevation all the way across. So we've got our high points, and now from here we are going to, I like to pretend that I am, like I said, standing at this point right here. I like to pretend that I'm standing at this point, and now you're going to get to see how great of an artist I am. I'm standing at this point, and I'm standing there, and I'm looking up, and I put my hands, and I point uphill. And from there, I look up and I say, okay, I'm going to come off this way, and I'm going to come off this way. So I can start here, but now I want to look for my high point. So my high point, I've got a high point over here, got a high point over here, and so if I follow this ridge, and when you're drawing a watershed boundary, your line should intersect the contours at right angles. So go through this point here. This isn't perfect, but we're following this ridge up. Oops. Following this ridge. I don't know why it keeps doing that. So we've got that much done. We're trying to make our way up to this high point. So we're going to keep following the ridge. We're at a place called the lump. We'll follow that up. So maybe it looks something like this. And then now we can see that water is coming down this way. So this is 3600. This is 3200 here. So some water is flowing off this way and not making it down to our point of interest over here. So with our two high points, to connect them and still respect that this is another stream going off the other direction, we could do something like this. Across. Something like that. So we've hit our two high points. And then come down, follow this ridge all the way down. And here I went a little bit too far. because there's another little valley right in here, and we can see the start of another little stream going off this direction. So this is going to follow this down here and come into here. So something like that would be the watershed delineated to this point. Because we can think about it, if a drop of water, let me get some blue here for water. If a drop of water were to hit right here, this point, it would fall down this way, get into the stream, and then continue on and go here. And likewise, if a drop of water were to fall right here, it would come in. These flow paths always cross contours at approximately right angles, technically, because that is the path of steepest descent, right? And that's the way that gravity would take the water. Okay, I'd like to do one more example of delineating using this USGS topo map. And so I'd like to choose our point of interest over here. So let's pick this point right here. And this is a little more bit suburban. And so this is our point of interest. Again, let's go around and look for some high points and find those. So we've got high point of 900 right here. Got a point of 920 over here. Got another, this looks like that's 920, so that's probably 930 right there. And that looks like 930. That's probably 940 right here. This looks to be like 930. You can see this contour continues around all this way. So this is a 930 point right here. And again, so this is our point of interest, our watershed 4-point, our watershed outlet. So again, standing here and sort of looking uphill, I want to find the ridges. So I can see a ridge that's coming up this way. Something like this. Doesn't look like these high points are really going to make much difference in this delineation here. And then coming up this way, looking up to the right or the east, it looks like this is another ridge following up this way. So I went up something like this. So if we clean that up a bit. So if we draw this out, we've got a ridge coming up to the east. It goes something like this. Okay. Now here we can see that water comes down. We've got sort of a high point here, and there's a valley sort of created in between. And then over here we can see that this is 930, 920. So water's not crossing the road, this Glen Ferry Road, and coming across down towards our point of interest. So it seems like the road is built along the top of a ridge. And actually, in roadway design, we design our roads to look something like this. So your road will have a curb potentially, come down, that's your curb. Then you have a little bit of a gutter. and then your road will come up and down, and then is this a line tool? Oh, that's so much better. So you come up to a crown and then back down, and another little gutter, and then your curve will go up and over, right? So something like this, and so you would have car driving here. This is your roadway. Again, I'm a great artist. And so this is called the crown of the road. And that allows water to come off of your road. So if a drop of water falls here, it's not going to come over this way. It's going to go down here, right? So we see that we've got sort of this road following along the ridge, and so we're going to operate with the assumption that our roadways look like this and that they're crowned, and so we can think that, we don't need to take into account the road so much other than to divide it. So we'll try and follow that and divide this watershed along the crown of this road. So we'll go back to our delineation color. And we'll continue delineating. So we'll come up here, staying in that 930 contour. And we're going to come down. We're going to try and follow this road. Again, this is not going to be perfect. But assume that we're following the road. And then here, we can come up, over, and across. And there we're making the assumption that perhaps there's some sort of pipe underneath the road that carries water this way. Because it definitely does look like this contour is crossing the road, and the water would be coming across our road. So we carry this down. Again, a little bit of following the road here, and then coming down. So this is approximately our watershed. So we've got this ridge, here we're following the road, here we're coming off the road, and so and actually I'm going to change my mind here after looking at this. What I saw was this here, so we're going to follow this road here. Take this like this. Because of this stream that's going down this way, I feel that we can safely follow, make the assumption that this road is crowned here as well, and that water from part of this road is going to get off and go down this way. So that would be our watershed to this point.